Hello, in this video let's discuss fourth question of today's contest. You are given an m into n 2D integer array grid and an integer k. You start at top left cell 0, 0 and your goal is to reach the bottom cell which is m minus 1 and n minus 1. There are two types of moves available. The normal move in which you can move right or down from your current cell. That is you can move to I to j plus 1 or I plus 1 to j from I and j. The cost is the value of the destination cell. So for example, if we reach I comma j plus 1, the cost is v of I j plus 1. If we move to I plus 1 j, the cost is v of I plus 1 j. And the second move is a teleportation move. You can teleport from any cell I comma j to any value xy such that grid of x and y is less than or equal to grid of I and j with the cost of 0. You may teleport at most k times. So from the whole path from 0 to m 0 comma 0 to m minus 1 and minus 1, we can use k operations such that from a value from any cell I comma j, we can move to any other cell with a value less than or equal to the present one, and we can use only at most k times. Find the minimum cost to reach m minus 1 and minus 1 from 0 comma 0. The constraints are n and m are up to 80 and values are up to 1e4 and k is only up to 10. So let's take some examples. So for example, we are at ing and if we are at ing and the value of this grid is 10. So from this, with the cost of 0, we can move to 9 with any cell with the cost of 9, with any cell with a value of 9 with the cost of 0, or we can move to any cell with the value of 8 with cost 0 and so on till 1. And in this way, we can use up to k operations in the whole path. So let's assume the most simplest one where there is no k or there is no k. So we have to find the minimum cost to reach m minus 1 and n minus 1. Then what is the way? It is very simple, right? So initial cost to reach 0, 0 is 0 itself because we start from that, so no need to take any extra cost to reach this. And then start looping through the rows and columns. And for example, we want the answer for I and j. How can we reach I and j? We can reach from I minus 1 to j if there is above row, and we can come from I comma j minus 1 if there is a before column. So if I is greater than 0, it means that there is above row, so there is a possibility that we will reach the present I and j from the above one. And then what is the cost? It is simply the cost of final destination. So in the destination, we are thinking about I and j. So the value is a of I and j. And there is some cost to reach the before the top one. So it is dp1 of I minus 1j. So in this way, for I and j, we can come from or we can come from left. So if we are coming from top, then the minimum value is minimum value of this, and the cost to reach this, and the cost to reach to this, which will be simply v of I and j. And similarly from left. In this way, after doing the whole loop, dp1 of I and j indicates that it is the minimum cost to reach I and j from 0, 0 without using any teleportations. So this is the simpler one that we can think of. But now we have to use at most k teleportations, where from a value of 10, we can go to any cell with a value of 9 or 8 or on so on till 1 in one operation. So in this way, we can have to do k operations. So for example, this is the very big grid that we have. Let's group the values by let's group the cells by value number, because the value is important here, right? So for example, we have a value 10. So all the cells with node 10 are the same important, are equally important. So in this way, let's try to think of the value independent of the cell. So let's assume that we are thinking with respect to the value 1. All the nodes, all the cells with value of 1. And then similarly 2 and so on. So from this, what we got? So the main idea here is we have to divide the whole cell with the form of values. So for example, we can use a map of vector value and a vector of pair, where every pair is I and j, which indicates the cell value, cell coordinates. So for example, we have one cell with a value of 1 at 0, 0. So the map stores that 1 have a single cell with 0, 0. For example, there are many cells with a value 2. So we will store all the coordinates of the points of the cells with value 2. So in this way, at any point of time, if we want the total cells with a given value, we can simply loop through this and we can find the answer without traversing the whole grid. So why we did this? Because here the values are important. So for example, we can move from any cell of value 10 to any cell of value 1 in one operation. So from this we got that the value is important. So simply we are using a map to store all the coordinates, all the cells with a given value. So how can we do that? It is very simple. So we will simply move through the loop and push the present cell to the map of value. So after this, we will get for every value what are the all cells with given coordinates, with the coordinates with the given value. And then let's take an example. So we have two different cells with a value of 1 and many different cells with 2 and many different cells with 6. So for now, let's assume that uh, the minimum cost to reach any of these 6 is 3. So let's assume that the cost to reach this is 3, to reach this 6 is 10, and to reach this 6 is 4. So the minimum cost to reach any of the 6 is 3. And similarly, minimum cost to reach any of these 2 is 7. And minimum cost to reach any of this is of any of 1 is 4. So for let's now for now let's assume that the value of k is equal to 1. So it means that we can do at most one operation where we can come from any higher value to any lower value. So from this what we are able to understand. So from 6 we can come to 2. From 6 we can come to 1 or any middle nodes as well. So with a value of from a cell with a value of I, we can come to any cell with a value less than I in one cost, like with cost 0 in one teleportation operation. So from this we are able to understand that we can update the values, right? So if we are able to reach 6 with the cost 3, if we so we assume that k is equal to 1. So now we can come to any cell with a value less than 6. So if we have a value, if we have the answer for any of 6 as 3, then what is the answer of 5? It is simply minimum of this 3 and any of the 5, right? Because we are using one operation. So in one operation, we can come from 6 to 5 because let's assume that the cost to reach any of the 6 is 3. So we reached this 6 and from this 6, we can come to this 5 in one operation, right? With cost 0 because it is that we can come to any cell with a less value. So if we find the minimum value for 6, then we can update in the minimum value of 5 also because we are using one operation. So if we are able to come to 6 with cost 3, then we can come to 5 also with cost 3 because the extra cost come to reach say 5 from 6 is 0 because we are using teleportation operation, not the normal one. So from this we got that grouping by values is correct, and then for every value we have to come from the higher values. Why? Because if we are able to reach the node 6 with the least value, then we can think of the least less cost to reach the less values as well, 5, 4 or 3. But if we start on less value, we can't do anything because in one teleportation operation, we can reach a value of lower cell from the higher cell. So it is better to find the answer for the higher one, and then we can update the answer as we are going to the less values from the highest value. So use other vector distance where it will store all the unique values in descending order, and then we will start mapping through distance, and then we will start traversing the vector from adjacency from the map we used, and then for every value. So we have 6, right? And we also have dp of 1 which is computed before without any teleportation operation, which is the most simplest dp ever. So now we will start doing for one iteration, and then we can conclude for k iterations. So for this we have 6, right? So find the minimum cost to reach 6. So from this we will traverse through the map and we'll find the dp1 of all the cells with a value of 6. And then let's assume that we got the cost 3. And then we will so the 6 is completed and the minimum cost to reach 6 is 3. And then start from 5. So start from 5. So in this what we can do, similarly we can traverse the all cells with value 5, and let's assume that all the minimum of this is 7. So without doing any teleportation operations, the minimum cost to reach 6 is 3 and the minimum cost to reach 5 is 7. But now we have k is equal to 1 because we are doing the first iteration. If the k is 0, we have originally returned the dp1 itself. But now k is equal to 1. So think about 1. So how can we utilize that one? We can move from 6 to 5 with the cost 0 in one operation. So we can update to 3, right? Because we got the minimum cost 6 to 3. So we can update all the cost of 5 to 3 also because we are using k is equal to 1. So in this way we got that we want two minimum values where minimum of 1 is the global minimum from highest value to the value till the value we are at, and minimum 2 is the cost that we get blindly from all the values of that value. For example, we have 654, and what is the minimum mn1 when we reach 5? It is simply the minimum cost to reach 6 and then minimum cost to reach 5, because if we have the global minimum, Then for the next value, then we can update all the values with the above one if this is minimum. So we want to do minimum values. The first one is minimum in the whole 6 or whole 5, and we will reinitialize it with int max every time we loop the loop. And then we will use the other minimum also, where it is the minimum cost to reach all the nodes from highest value till the present value. So hope you got this. Let's check the code of this one. And then also, what is the initial vector? Initial vector represents the cost to reach only, right? For example, we have, let's assume the initial one is a, and for example, a of 0 comma 3 is 10. So what does it mean? Does this mean that the answer to reach 0 comma 3 is 10? No, it is simply the value at 0 comma 3, but not the answer. But here what we are doing, so we got the minimum value for 6 as 3. What is this 3? This 3 is the minimum answer to reach 3, not the value at that cell's rate. So after traversing 6, we will get the minimum value. What is that? It is the least cost directly to reach that cell. For example, if this is 3, then we can simply return 3 because this is the cost, not the value. And for 5, if the minimum cost to reach this is 7, we are updating all the values with 3 because we are using k is equal to 1 now. So after updating 3, so what this 3 indicates? This 3 also indicates that this is the minimum cost to reach 5, but not the initial when, which is simply a of 0 comma 3. So after doing k is equal to 1, what are the new errors that are found? So the first one is simply the initial one, and the second one is updated dp of 1. But there are two different kind of values. What is one? The first one is the cost to reach that cell, where we have updated now, and the second one is simply v a of I and j, which is the cost to reach that path. So hope you got. We have two different type of arrays. The first one is where it is 3. It means that the final cost to reach this itself is 3. And initially, if there is, for example, a 0 comma 3 is 3. What does this mean? It is not the final cost. It is simply the cost at this node, and this is the cost when we reach this cell. And if dp of I and j is 3, what it means? It is the minimum cost to reach that itself, not any other value. So we have two type of vector. One is direct cost, so other is cost to go to etc, like the initial one. And this is the function to update the dp1. So this is very simple. What is this v? We have v and a, and then we are initializing with v of 0 0, and then we are looping through all. This is simply exact the original one. But what is the difference? The only difference is we are initializing with v of 0 comma 0 because this is the cost to reach itself. So we have many different operations, and we also have the cost initially to reach it. So simply both of minimum will be the final answer. So dp of 0 is equal to minimum of v of 0 0, and then if there is above row, find the minimum value to reach this. If there is left, find the minimum value, and then finally use minimum of dp of v of I of j, which we have not written here, right? We have not written here. Why? Because initially we did not find anything, but when we are at this position, we already found dp1 of a and g initially. We are just updating the values, so we are using this also here, where where dp of I of j is the minimum cost to reach this, and v of I is j is the minimum cost where we can reach the cell when we are utilizing the previous teleportation, and we are updating for the teleportation. For example, initially we have dp1, right? What does dp1 indicates? That we are using none of the teleportation. So this is the answer for k is equal to 0, and now we are doing the answer for k is equal to 1. So after k is equal to 1, we traverse through all the cells of value 6. We got some minimum value, and then we are traversing through 5, and then we updated the values and so on. So after all this, we will get the new dp1, right? So what that contains? It will contain the, this is the new v, and then we will use this function to get the new dp. So that after using teleportation, we updated some values, and then this is the final dp that is the best ever possible after doing at most one teleportation. Why at most one? Because there may be a case where it is better not to use teleportation. So after doing k is equal to 1, we will get the best answer when we use at most one teleportation. And why we used only one? Because for now we thought only about k is equal to 1, right? So for example, we have many values with 6 with cell 1, and we have many values with value 6. So what we just thought? We just thought about one teleportation. So we just thought to use 6 to 1 or 6 to 5 or any one. So after this, we will get only a subset of answer where this can be reduced further as we increase the k. So hope you got this. In the first operation we dealt till now, we used only one operation. And after this, we will get the new dp1. What it will contain? it will contain the least answer if we use at most one teleportation for every pair I, j. And then we will use the same loop again. This is exactly like Bellman Ford. Hope you know that. So we will get the answer for at most one, right? And then use the same again for k is equal to 2. So that the inner computations will be merged together and we will get the new DP when we use at most two teleportations. And so on till k is equal to k. So hope you got this. Let's check the code for more clarity. So simply we are inputting the values and we are finding the DP1 initially, and then use adjacency just to store the values with respect to a value, and push the all distinct values to distinct vector, and just push the cell to adjacent of value. After this, what does ADJ represent? It represents that it contains a vector of pairs with cells I and j with a value of 1. So we done this and we sorted the distance in the decreasing order by decreasing order, because for example we reached 6 with cost 3, we can reach the one with cost 3 also. So it is better to reach from top to bottom so that we can update globally. So start from 0 to k and use a new vector, and then initialize mn1, which is the global minimum value, and then loop through the distant values, and then minimum 2 is equal to the minimum of this set, only of the cells with a value 1, and then loop through all the values and then find the minimum values of each DP. So we are doing first iteration, right? In the first iteration, what is DP of 1? DP1 is simply the answer when no teleportation is used, because this is the DP1 last we updated. So for every k, for every new t, we will get the updated DP of 1, which indicates the best answer for the before teleportations. And now we are using extra one, so this will be updated. So this is the minimum values of these, and then find the global minimum. So mn1 is the minimum of total and minimum of this, which is mn2. So we will get the new minimum, and then update the values, right? Update the values to mn1. Why? Because we discussed that we are using one teleportation now. So in this one, we can use the top values. So just update v of I1 to mn1. So after these both, we have new v and we have new a also, because we simply updated dp1, right? Because we are using dp1 to update mn2, and simply we are using that in v of j. So it is simply the updated dp1. So find the new answer where v is dp1 and a is the given vector, and this is also exactly, this is updating dp of 1. So after updating, we will get the new dp1. We got the new dp1. This is the new dp1, and then update the values finally for this key. So we got dp1 also, and then just update with the minimum value. Let minimum value of all the time. This will be updated every time if there is a less value. For example, at k is equal to 3. At before k is equal to 3, we have a cell with value 10 with a cost of 10, and we got with 8. This is the new dp1. So update this with 8 finally, because we used k teleportations and we reached 8. So this is the final answer. So simply loop through those and then make dp1 is equal to the new dp1. This is simply like just by call by reference. So we can use dp1 in the place of v, and then we can use just by call by reference. So that will update our answer. In this way, this is the new dp1 after one teleportation, and then this loop will run again because we got the new dp1, right? So with this new dp1, we can again do one teleportation. Hope you got this. Initially, in the first iteration, there is nothing. The original is exact dp1, but now this dp1 is updated. So now we can assume we are using other teleportation, which is the exact same logic. So this is the new dp1, and then similarly exactly this goes. And finally, we will get the dp1 as the best one after using k teleportations. So return that one. So hope you got this. If you have any doubts, comment below. See you in the next video.